Hey guys, good morning. How are you? Yeah, I'm recovering. I'm recovering for you only. Nowadays, I'm always thinking about my students. I told to my brother I want to recover at any cost by Monday. Then he said, skip all the classes Saturday and Sunday. I skip all the classes. They scold me a lot, I think. That is. See, all the classes are cancelled. 9 a.m., 12 till 4 o'clock, 9 to 4. That is. The tour is badly affected me. That is. So what you have done 2 days? Huh? Eating, sleeping, huh? No assignments. Assignments are done. Venki, done. Soro, done assignments? No? What you have done? गर्लफ्रेंड के साथ घूम के ना क्या किया तुमने? 42 count, 33. Wow. 35. Why this is become 42? Any reason? Because it is in the class, huh? Huh? Deepak, that is the reason. This is in the class only we have done, right? On the Friday. That's why you have written. So it's out of the class, you are not start doing that. अरे यार क्या रे. You want job or not? Data science. Don't want job. You want job. You want money, but you don't want assignments. Huh? Murli, tell me. Tell me, Arun, Nikita, Priyanka, Prishti, Utkarsh. And everything. Okay, today is the last class of linear regression. Chalo. We are almost at the end. We'll complete that. Tell me what we have done from starting onwards. Bolo, everything. Tell me what is the first point in linear regression? What is linear regression? First one, direct. Okay, first is what is linear regression? What is linear regression? Tell me, Shravya. Shravani, tell me. Equation. Equation of linear regression. Bhairavi, tell me. Next one is what? Follow next one. Simple and multiple linear regression. Simple, simple and multiple linear regression. Prishti, tell me. What is the next one? Arun saying the finding coefficients. Finding coefficients. Next what? You should say no. Every day I'm writing. You are still you are taking your pages back and front. Like, क्या रे? Huh? Every day I'm dictating. Finding coefficient. That means error. Again error term. Next what is error? SSC term. Next what? MSC. Whatever I'm writing that you say no. After SSC, MSC. Then RMSE. Then loss cost function. Then, okay, how do you find the coefficient? OLS method. OLS method. And then interpretation. Then interpretation. After interpretation done, RSE. After RSE done, R square. R square को drawback है, correct? What is the drawback of R square? What is the drawback of R square? Increasing variables are R square will be increase, and that is called what? Overfit. So that's why we learn what? Underfit, normal fit, and overfit. You want to be normal fit or overfit or underfit? Then where you are doing assignments? Huh? Where you are doing assignments? You are not doing assignments. Then simple linear regression used to relationship between which one will predict another with the correct. Normal fit is done. Then normal fit, then bias and variance trade-off. What is the famous mantra for overfit? Tell me, low bias, high variance, or high bias, low variance, or low bias, low variance? Low bias, high variance. Low bias, high variance is nothing but what? Overfit. Low bias, high variance is nothing but overfit. Let's see this questions. Chalo, we will do something. Linear regression. Interview questions. Which is done, which is not done, we'll see that is. What is linear regression? How does it works? Can you able to say? What is linear regression? How does it work? Will you able to say or not? Say yes or no? At least I'm confident that at least after studying also I can understand, I can say, sir. What is the assumptions of linear regression that we'll discuss today? Okay. What are the outliers and how to detect them, that you know that? How do you determine the best line? How do you determine the best line? Tell me. How do you determine the best line? But how can you minimize the cost function? By finding the coefficients. What is the difference between simple linear regression, multiple linear regression? Simple means one variable. Multiple means number of variables. Very good. Multicollinearity, I will tell that. But we already know collinearity meaning, right? Logistic regression. What is the common types of errors? Hmm. Common type of errors. Bolo all type of errors. Bolo all the errors, no? ट्रेन एरर के मतलब क्या है? ट्रेन एरर मतलब क्या है बोलो? How can you differentiate what is the train error and what is the test error? Train input data, which output? Train input data will pass to the model, and then model will give the predictions. That predictions will compare with the train output. That is called. Everyone know this concept or not? If you still doesn't know this concept, ask me. But otherwise, you will definitely underfit. That is. What the difference between dependent and independent variable? Tell me, who are the dependent variable? Who are the independent variable? Input variables. That is. What is the interaction term? Interaction term linear regression. Bias or coefficient interaction term. That is. Okay, leave it that is. I will tell that is. What is the difference between biased and unbiased estimates? Bolo now, bias means what? Intercept. Unbiased means what? Coefficients. How do you measure the strength of the relationship? Who will give the strength of the relationship? R square value. R square value will give the explainability. That is population regression and sample regression. That is, if you take the population means all the sample that will come. Non-linear, linear regression. How can you tell that? Linear means power kitna? Non-linear means power kitna? More than 2. That's it. That is a non-linear and linear. What are the common techniques used to improve the accuracy? That we will see that. So you are able to say most of the questions. Very good. Very good. Very good. Linear regression is very, very important. Linear regression is very, very important. So we stopped our discussion at if we increase model complexity, R square value will be increase. R square value will be increase. If we use all the variables, then R square value will be equal to approximately 1. This leads to model overfitting. To avoid that, we have two things. One is we can use the concept is called adjusted R square. And second one is we can select only the important features. We can select important features. That's the drawback, right? What is the drawback here? Model complexity increases, R square will be increases. What is the meaning of model complexity? If you use all the variables, then R square value will be equal to 1. That means model overfit. So adjusted R square is like this. Okay, I will tell the behavior. Then you will easily understand. R square value maximum equal to how much? 1. Minimum how much equal to 0. But adjusted R square value maximum equal to R square value only. Maximum equal to R square value only. And minimum equal to minimum 0 only. Minimum equal to 0. That is equal to adjusted R square. So you can say like this. So what is the meaning of this? What is the meaning of this like this? Suppose the equation is like this is there. Y is equal to beta naught plus beta 1 into x1. Beta 1 into x1. For this, you will get two values. One is R square value you will get, and adjusted R square value also you will get. Two values you will get. R square value and adjusted R square value. Let us assume that R square value is equal to 70%, and adjusted R square value also 70%. No problem, that is. It is a no problem. We know that R square value is maximum how much ma? It will go to 1, which means which percent is called 100%. And adjusted R square value maximum how much? R square. So 70% means 70%. That is the maximum. It can't go to 71. It can't go to 71. It is 70. Now next come to the one more thing is called r square. R square is equal to, when suppose you added a new variable, one more variable, we know that when I added beta 2, b2 into x2, definitely r square value will be increased. That is called, suppose 75. Give me 1 minute. I share. So now we already know that x1, x2 added, definitely r square will be increases. Then adjusted r square equal to also 75%. No problem. Here also no problem. So no problem. No problem. And here also no problem. Then suppose y is equal to beta naught plus beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3. Suppose I added one more thing. Again, r square value, what happened, ma? Increases. Suppose you make 80. If this is a problem, then adjusted r square will be decrease. If this variable x3 makes a problem, if x3 makes a problem, then adjusted r square will be, suppose, less than 80. Maybe it is 79. Then you should feel that something is going wrong. Then something is going wrong. Now observe the pattern. What is the first one? Y equal to beta naught plus beta 1 into x1. What is the r square value? What is the adjusted r square? No problem. Next, x1 and x2. What is r square? What is adjusted r square? No problem. Then when you added one more variable x3, what is r square? Then adjusted r square? It is a problem. It is a problem. So adjusted r square will be tell that. So it is a problem. Adjusted r square. So now the adjusted r square formula. Voice is buffering. Can you please confirm the chat, others? No, yes. What? No, yes. All okay. What is VIC? Voice is clear. Voice is clear. Give me 1 minute. Huh? Give me 2 minutes. Huh? Can you search in the Google what is adjusted R square formula meanwhile? I'll be back in 2 minutes. Sorry for the inconvenience. I'll just have a phone call and come. Sorry, guys. Yeah, the problem is going on some personal problem, Archana Nayak. That is, my wife has given same chargers in my laptop, her charger and my charger. Now she has office meeting at 10 o'clock. She don't have charging. That is a problem. Sometimes, typical wives, they're doing like that only. Tell me, explain me the formula. You understood the formula, right? Tell me, what is the formula? Adjusted R square rated on the based on the what? R square. What is the numerator is there? N minus K, K minus 1, huh? N minus 1, huh? Arey, what is the numerator? Forget about that. Bolo N minus 1 divided by N minus P minus P R K, both are same only. Okay. Okay. वो P equal to 0 है तो क्या होता? Now tell me, now अभी बोलो total formula. Total formula. 1 minus R square. R square nothing but not squaring, okay? It is a R square. R square. 1 minus R square into 1 minus, like this. This is the total formula, right? Is it correct or wrong? Correct or wrong? Correct or wrong? Hey, Murli, tell me correct or wrong? Murli is busy. Tell me, Murli. He's not listening at me, although. क्या रे Murli? Huh? I'm talking Murli. He's saying that my name is not Murli. Tell me, this formula is correct or wrong? Which bracket? 1 minus ఇక్కడ బ్రాకెట్ వల్ల చేస్తే తర్వాత ఏమవుతుంది అంతేనా? ఇక్కడ ఒక పెద్ద స్క్వేర్ బ్రాకెట్ పెడదామా? ఇట్లా పెడదామా? సరిపోద్ది అప్పుడు? సేమే కదా? ఓకే. అయితే చూద్దాం ఒకసారి. ఓకే, లెట్స్ సి. సపోజ్ దిస్ వాల్యూ ఈక్వల్ టు 0. This value equal to 0. This value equal to completely 0. When p equal to 0, okay, then this value will become 0, and this value will become 1, and then this is open the brackets. This is 1 minus and this is plus. So that's why adjusted R square maximum value how much? R square. Understood now? I will repeat again. See here. I will take the paint and I will write here. The formula is like this: 1 minus R square, okay, into n minus 1 divided by n minus p minus 1. Maximum value of adjusted R square how much? R square. Okay, maximum value of adjusted R square how much? R square. That means if suppose this value, this term p equal to 0, then this value, this is numerator, denominator cancel. Then what will come? 1 minus of 1 minus R, correct? Then 1 minus, now if you open the brackets, what will come now? 1 minus 1 plus R. Then 1 minus 1 how much? 0. So that's why adjusted R square maximum value how much? R square. Suppose if this P is equal to so much high, then suppose this is equal to 3, this is equal to 5. What is this entire value? 3 by 5, 0.6, correct? Now let's come to here. Understand how I am doing. 1 minus R into 0.6. 0.6 multiply karo. 1 minus 0.6 minus 0.6 into R. That is equal to 0.4 plus 0.6 into R. If the value is huge, definitely your total adjusted R square will become now less than this R square value. Less than this R square value. Suppose this is 0.7. Assume that 0.7, that is. It is assumed that. Then multiply that. 0.7 into 0.6, how much? 0.042. 0.042 plus 0.4, how much? 0.4 only, no? That means less than R square. So two cases. So we'll write the two cases. Case 1. Write it case 1. First note down the formula. I will write the cases now. Case 1. Case 1. Case 1. P equal to 0. P equal to 0. So P is equal to number of predictors. P equal to number of predictors, number of variables. That we have already seen in the last class, right? Have you remember? Number of variables. In the last class, we discussed the same formula with RSC. How many have remember that is? What is the latest one? This was the latest one. 100 fit. This is, have you remember here? N minus P minus 1. P is equal to number of variables. Everything I explained before, ma. Okay. So you need to be very, very careful. This is N minus P minus 1. So P is equal to 0. When P is equal to 0, adjust R square, what will be happen? Adjusted R square. Now just calculate it in your notebook. That's all. Everyone please calculate it. P equal to 0. P equal to 0. Please calculate in your notebooks. Then this become like this. And this become 1. And if you open these brackets, understood till now, everyone? Can you please confirm the chat? Adjusted R square value now, what is the value of this is called? R square. So that's why we say that maximum value of adjusted R square is equal to maximum value of adjusted R square equal to R square. Any mathematics you need to do like this only, ma. How I am doing, you need to do like this only. Actually, this is in our professors also taught in engineering the same methods. Unfortunately, we had done that time. That means you need to take P equal to 0 always and P equal to maximum always. Two cases. P equal to 0. Sometimes three cases also. Middle, low level, middle and upper. That is. Now case 2. Now case 2 equal to P equal to maximum. Case 2. P equal to maximum. Maximum suppose let's say 100. Let's say 100. Now the same formula. Equal to 100 like this. Correct? Do it in your notebook now. It is 101. 101. Suppose n is equal to some 1000 observations are there. Suppose n is equal to 1000 observations. Definitely numerator value will be more than the denominator value. Huh? Then what happen like this if you do like this? The value will be modified. The value will be modified. This is. N is equal to 1000. N is equal to 1000. You don't need to get the exact answer. You don't need to get the exact answer, but finally you can say that at some point of time, adjust R square value less than R square value. Less than R square value. So if you do like this is a very, very important. At which variable? At which variable? At which variable adjusted R square value less than R square, that indicates model is going to be overfit. Model is going to be overfit. Then you will not use that variable. Then we will not use that variable. Then we will not use that variable. Understood, Saurav? Then we'll not use that variable. So that you can see here problem 1, problem 2, problem 3. If you see this is don't have the problem, no problem. This is the no problem. And this is the no problem. But if you see this kind of approach, with this kind of approach, it is a problem is there. The problem is there. Understood? And what is the maximum value? They will ask you that question called what is the maximum value of adjusted R square? What is the maximum value? That is called R square value. So if R square value is less than that, then that is a problem. That is called adjusted R square. So R square and adjusted R square is a very, very important. R square and adjusted R square. Venki, happy now? Yes. Venki thought that without discussing adjusted R square, I close the linear regression. Okay, that is. Second thing is select the important features. Select the important features. You want to note down? Any doubts? Can you please confirm the chat? Can you please confirm the chat? Clear? So will you able to explain difference between RSA and R square and adjusted R square? Will you able to explain the difference between the RSA, R square and adjusted R square? Can you tell me once? What is the RSC? Residual standard error. What is the meaning of that? Very good. Even we find the true regression line, we reach our conclusion, but even though we are seeing some error, simple. We reach our conclusion, we got our best solution, but still I am seeing the some error. That is called residual standard error. That is the lack of fit. That is the lack of fit. So then what we learn? R square. R square is nothing but goodness of fit. And you know about R square. What is the R square formula? 1 minus sum of square error by total error. That is. So maximum value. What is the definition of R square? What is the definition of? Very good. Correct. What is the drawback if you know R square? Number of, yeah. So then model leads to overfit. Then model leads to overfit. So you are able to get the answers now. So question here, important question they will ask you on this one. So what is RSC Pakka? They will ask like this. And question number, and what is the definition? What is the definition of R square? And next, what is the formula? What is the formula? Then what is the drawback? What is the drawback of R square? What is the drawback of R square? And then we'll definitely say that overfitting, that is model complexity thing. Then they will slowly leads to overfit concept questions. They will ask you like this. And then how to overcome this, then adjusted R square, then adjusted R square. So like this, they will interconnect the questions. The question will be connected. Because after you know you already find the linear regression equation, because you by using OLS method, you know that. Then what is the next question? Evaluation, right? That evaluation is what? RSC, R square, adjusted R square. That is the evaluation process. So every model, how you are developing is important, how you are evaluating is important. That is the life cycle of data science. Have you remember the life cycle of data science? Understand the business problem, data gather, data pre-process, EDA, model development, model evaluation, model deployment. Have you remember or not? Say it. Say again. Understand the business problem, data gather, data pre-process, EDA, then model development, model evaluation, model deployment. If you remember this cycle, then you remember what you want to learn. Correct? So EDA already done. Now we are in the process of model development. What is the one model we are choosing? Linear regression. Linear regression, 1 minute. Linear regression model we already developed. How we developed? By using OLS method. Then what is the next one? Evaluation of that model. What is the evaluation metric? RSA, R square. Then R square we have a drawback is there. That's why what we are moving to? Adjusted R square. Yeah. But model also is very important to select the features. In order to select the features, we need to write one hypothesis. hypothesis in linear regression. Hypothesis in linear regression. Which one is you will think like that, okay, when I am adding TV variable, my adjusted R square is decreasing, so I will not add TV. Like that. So what is the null hypothesis here? Null hypothesis that is equal to H naught. There is no relation between dependent and independent variable. There is no relation between independent and dependent variables. That is the hypothesis. It is very, very important. They will specifically ask you what is the hypothesis in the linear regression. And second one is alternative hypothesis. You already know hypothesis testing, right? Very well. We done many times the problem. Alternative hypothesis. Alternative hypothesis. HA or H1. There is a relationship. There is a relationship between the dependent and the independent variable. And your equation is equal, suppose y is equal to beta naught plus beta 1 into x1. So this is the equation. In this, from this equation, I have made my hypothesis. This hypothesis especially is related to linear regression only. Okay, what is the hypothesis here? There is no relation between independent and dependent variable. And what is the alternative hypothesis? There is a relation between independent and dependent variable. Now, this is the verbal, right? This is a verbal. Now, how can you make this is a some mathematics kind of thing? Like we know, right? What is the verbal thing? Virat Kohli average equal to 50. The what you have written mu equal to 50. How can you write here? From this statement, how can you make some mathematical thing? Tell me. No, ma, here made me the statement. No, first tell me the statement. Virat Kohli average equal 50 is the verbal or non-verbal? That is a non-verbal. After that, what we have done? No. What we have written after that? Like that, tell me the term here. How can you make this statement a valid statement into here into some mathematics statement? Y equal not equal to x1. Correlation. You people are not understanding what I'm saying. You are understanding or I don't know, but Saurav, you are not at all understanding what I'm saying. Null hypothesis equal, suppose I'm saying VK average 50. Okay. The same H naught, how can you write? Mu equal to what? 50, right? That is equal 50. This is the English statement. This is what? Some mathematics, right? Same way, tell me about this. Same way, tell me about this. How you are writing like this also, you need to write like this also, right? Tell me that. Which one? Tell me x. X not equal to 1 by k. Who is k? K into I. Who is I? I is also a variable. Why? Srishti has given. This is the answer. Equal to 0. Tell me it is correct or wrong. बीटा 1 जाए तो 0 है तो क्या होता? बीटा 1 0 है तो क्या होता? This one what happened? X gone? When X gone, what is this meaning? That you need to think. Understand? Understand now? Not 1 by k into I, y, b. That is not. You need to think like that from the equation perspective. At least you try it, that is better, but you need to think like this. Beta 1 equal to 0. Note on this. No dependency. What is the alternative hypothesis? HA. HA. Beta 1 not equal to 0. Not equal to 0. It is very, very important. 0. Again, same steps. This is the step 1, step 2, and what is the step 3? I'm writing here step 1. Step 1. Step 1 is equal. What is the step 1? Making a hypothesis, correct? This is the step 1. And this is the step 2. This is the step 2. Correct? And what is the step 3? Step 3 significance level. Significance level. Open your pages. Do it. Alpha is equal to. This will be done questions also. 0.05. 0.05. And step 4. Step 4 rejection and non-rejection area. No one will ask you to solve ma. Okay. Rejection and non-rejection area. Rejection and non-rejection area. And then what happened? Step 5th. Step 5th. Step 5th is nothing but test. So here either you need to conduct Z test or T test. So whenever your number of samples are tell me Venki, less than 30, then go for T test. N is equal greater than 30, then go for Z test. That is the only difference, ma. Then go for Z test. T test and Z test both are used to Z test and T test. Z test and T test both are used to conduct mean type, mean or median type, mean or median type of test. That means single value will get, right? That is F test. F test is used to conduct to find variance. F test and chi-square also. chi-square. You see, variance power is how much? Mean power is how much? Like that. Like that you need to think. Okay. So mean power is 1, then Z and T test, F test and chi-square test is used for variance. If you want to do if you want to compare two population variances, same or different, then go for F test. So you'll conduct the test and step 5th from the test, what you will get? From step 5th, from the test, what you will get? From the test you will get which value? P value. What you will get? P value. Now step 6, what is the step 6? Now P compare with alpha. Now P less than alpha. Reject the null hypothesis or not reject the null hypothesis? P less than alpha hai to reject the null hypothesis. Reject the null hypothesis. P less than alpha hai to reject the null hypothesis. This is the process, right? This is the process. You will get like this. Now listen very, very carefully. How your output will be get now you will see. Now listen very, very carefully. Suppose you have a y is equal to beta naught plus beta 1 into TV plus beta 2 into social media plus beta 3 into TV. What is the newspaper is there? Suppose newspaper is there. Then you will get like this. How you will get like this is you will get a beta naught value. You will get some beta naught value. You will get beta 1 value. You will get beta 2 value. You will get, and you will get standard error. You will get T value. You will get P value. Suppose you will get like this. You will get beta naught value. You will get beta 1 value. You will get beta 2 value. This is your output. Output look like this. Beta naught, beta 1, beta 2. And here, that means here the variable is TV. Here social media. Here is a newspaper. And here is the your coefficient, intercept. Here is the intercept. Here the values will come. Suppose beta not equal to beta naught value, coefficient values. Here what will come? Here the coefficients will come. Here the coefficients will come. Coefficients values. So here what is the value? Suppose 100. Here 0.3. Here 0.2. Here 0.1. Immediately you need to understand your equation will be look like this now. Your equation will be now. I'll just write here. Not going to lab nowadays? Going? Very good. So 0.1, that is. Now your equation will be. Now tell me how your equation will be now. Instead of beta naught, what is the value now? 100. Instead of beta 1, what is the value? 0.3. Instead of beta 2 value, it is the value 0.2. 0.2. Instead of beta 3 now, 0.1. Very good. Now this is the coefficient value. Here also some P value will be available here. P value. What the value will be available? P value. So P value for 0.3 is 0.001 and this is 0.1 1 and this is 0.3. Like this is there. Now you need to compare. You need to compare. Is really P less than alpha? Is the P less than alpha? This is, tell me. What is the alpha? Suppose alpha is equal to 0.05. Is P less than alpha? Yes. Then keep this variable. Then keep this variable. Then P less than alpha. Again. Then don't keep. Remove this. Which one you want to reject? There is no relation. That means you are saying relation is there. Okay. Understood? Is P less than alpha? No, right? It is a P greater than alpha. Again, don't confuse, right, in this. Already confusion is over. That state is over now. Okay. Now here, it is a P greater than alpha, less than alpha. P greater than alpha. Okay, we'll come again. We'll avoid the confusion again. Okay, tell me this. Slowly we'll come. Now tell me this one is P less, the first one is P less than alpha or P greater than alpha? First one is. Please confirm in the chat. P less than alpha. Pakka? What is the P less than alpha meaning? P less than alpha means what is the meaning? Reject the null hypothesis. Then what is your conclusion? Relation is there or no relation? Relation is there or no relation? I will hit you if you say again. Relation is there or no relation? Then what you are saying? 3 times you said no relation, no relation, no relation. I am asking 3 times what is that, what is that, what is that? You are repeating same answer, same answer, same answer. Are kya re? Is the relation is there? Relation is there. That is the conclusion. Then keep this variable. Then keep this. Then keep this variable. Next question. P less than alpha or P greater than alpha? P greater than alpha. What is your conclusion? What is the conclusion? No relation. Conclusion is the no relation. No relation means what? Social media is not related with Y. So don't keep that variable. So don't keep it. Don't keep it. Then what is the last one? P less than alpha. What is your conclusion? Again, no relation. That means again, don't keep it. Don't keep it. So finally, your output will be only settled with TV. That means out of 3 variables, you are removing the 2 variables. That is called feature selection. That is called feature selection. So we are selecting the features by using a hypothesis testing p-value. Understood? Can you please confirm the chat? If you want to repeat again, I will repeat again. Okay. Make use of this. Want to repeat me? I will repeat again. I will open that same thing again in the PPT. Okay, we'll conclude that. We'll conclude that. That is very easy, ma. That is very easy. Don't confuse in that. Okay, linear regression. PPT. I'm opening the linear regression PPT. So this is the question. What is the question? A production house Mumbai wants to analyze the relationship between the promotion and sales. And this is the question you already know that is. And what is the second one? That's the data set. And third one, what is the linear regression? This is the terminology. Simple linear regression, multiple linear regression, you already know. Dependent variable means you know. Independent variable means also you know. Coefficients, intercept, error, everything you know, right? Pakka? Now come to here. I will go to the last output. See here. P-value promotion के लिए 0.00019. P-value. The output will be like this. Coefficient. This is the 88 is the coefficient. 2.4 is the coefficient. Standard error. If you calculate the standard error of the data set, you will get these 2 values. T value of this. Based on the T value only, you will get the P value. from the table, correct? Like how the Z table PDF is there, like T table PDF also will be available. T table and F table also will be available. Every table will be available. Now here what is coming 0.00019. Tell me it is an important variable or not important variable? Promotion should keep or promotion should out? Promotion should keep. So that is the conclusion. That is the conclusion. Now you see here, that is a very, very famous linear regression output. Linear regression output analysis. Output analysis. Linear regression output. Now just go to some images, okay? Now you see here this. Now this is the linear regression output here. Now constant coefficient value, this is the value. First column is clear. Everyone, what is the coefficient meaning? Coefficient meaning we write with OLS method formula. If you substitute that, you will get the value. Standard error. You know how to find the standard error. What is the formula of standard error? That is sigma by root over n. For the corresponding observation, we will get the standard error. T value. What is the T? T value means T test. T test. What is the T test here generally? That is coming 17.296. For the 17.29. Sometimes what happens, you'll get star marks, like triple star is there, right? Triple star means what is this comparison significance? Triple star means the comparison is nothing but 0.01 comparison. That is, it is 0.000016. E minus 16 means what? Divided by 16 zeros. That means 0.00000. That means definitely it is in. Income is definitely in. That is. Sometimes you will see like this. It's not clear. T value, P value. It is not clear. Now this we'll see now. You see here, it is how much is there? 0.00036. That means again this Visa weekly change is in. It is an important variable. Finally, for every variable, you have one P value attached in the output. Okay. For every variable, you have a P value attached in the output. You need to pick that it is important or not. So for that, you need to explain about the hypothesis testing. What is your hypothesis here? Tell me. What is your hypothesis here? Tell me. There is no relationship. And what is the alternate hypothesis? Your hypothesis up and down, then your analysis also up and down. That's why follow the standard hypothesis. Follow the standard hypothesis. Very good. I'll show you one more thing. Now you tell me here. Out of these three, out of these two, which one is in, which one is out? XZ. Tell me. Alpha. Which one you want alpha? You are saying 0.44 alpha कितना given चाहिए क्या alpha चाहिए क्या? Huh? You are saying 0.44 alpha चाहिए क्या? वो significant scores है ना? What is the significance? 0, 0.001, 0.01, 0.05, 0.1. Alpha is almost only that only. 5% or maximum 10%. Not 40, 50% alpha. Okay. That's why what you are getting answer here. 0.4, 44%. That means this is out. That is out. Are you following me, ma? Can you please confirm the chat? Arun, Nikita, Srishti. Arun, Nikita, Srishti, Utkarsh, Priyanka, Nagarani. Are you following? Yeah. Now, how much is the degrees of freedom is there here? Why 97? What is the formula of degrees of freedom? N minus P minus 1. How many P's are there? 2. So 100 minus 2 minus 1. How much? 97. So 97 is the degrees of freedom. In output, everything will be there. R square will be there. Adjusted R square will be there. Degrees of freedom will be there. Coefficient value will be there. T value will be there. Residuals. What is the minimum residuals? Maximum residuals. How the residual graph is going. Everything. Everything will be there in the linear regression output. So linear regression is a kind of a all combinations together. It will give the output means errors will provide, RSC value will provide, R square value will provide, adjusted R square value will provide, everything will be provided. That is statistical way. Now I will do one more thing now. In this, which is in, which is out? TV, radio, newspaper. Tell me answers in the chat. TV and radio is the in, newspaper is out. That's why the stars are there, right? Remaining is not stars are not there. Like that also flexibility is there some in with some packages. Okay, if packages is you are using a good linear regression related package, that flexibility will come. So why this is out? Because the value is equal to how much p value? 0.79. You know that p less than alpha means that should be in. P less than alpha means that should be in, otherwise it is out. Any doubts in this? Interpreting of linear regression. Any doubts? Can you please confirm the chat? No doubts, right? Yeah. And we have one more last concept is there left, and that is called assumptions of linear regression. Assumptions of linear regression. Assumptions of linear regression. First of all, the basic assumption follows linearity. Follows the linearity assumptions. If this follows this only assumption, then only you need to apply the linear regression. Otherwise, you should not apply the linear regression. Follows the linearity. There is no multi collinearity between variables. Errors should follow normal distribution. Normal distribution. There is no autocorrelation between the errors. Errors follows the same variance. can say that heteroscedasticity. Heteroscedasticity. At least you need to say these 5 assumptions in the interview. This is the pakka question, 1000% question ma. Any interview, they will ask this question. Assumptions of linear regression. Assumptions of linear regression. 1000% question. There's no doubt at all in that. 1000% question pakka. Assumptions of linear regression. First assumption is follows linearity. Second one is there is no multicollinearity between the variables. If you observe first two related to variables ma. First two related to variables. First two related to variables. And second three related to errors. Second is related to errors. First one is follows linearity and second one is what? No multicollinearity. And third one is error should be follows normal distribution and there is no relation between the error, that is called autocorrelation. And for last one is called heteroscedasticity. So we'll learn tomorrow, we'll learn about very detail about this and we'll close that. Okay. And after that, we'll start the logistic regression also. You will take only 15 minutes time for this. Follows linearity. There is no multicollinearity. Error should follow normal distribution. No autocorrelation and heteroscedasticity. Pakka question ma. That is. ठीक है? चलो. By tomorrow we can close the linear and we can start the logistic regression. I spend a lot of time on the linear regression ma. So I hope everyone should explain very well in an interview all the things about linear regression. That is your job now. Because linear regression, some section of people they'll stress only on the linear regression because they will learn only that only. Okay. And that is the only big one. This is the only big one that is. Chalo. Thank you. Thank you so much. See you tomorrow. Once the enrollments are closed for the latest batch, I will take some more time. Okay. We're starting almost 9:15, right? I'll take till 10:45 at 11 o'clock. That is, let's see.